The depth of electrical coverage on exams hinges on the specific exam's focus. Generally, anticipate a broad overview encompassing several core areas. Basic electrical concepts will likely be tested, so a solid grasp of voltage, current, and resistance is paramount. Voltage, often measured in volts, is the electrical potential difference that drives current. Current, measured in amps, is the flow of electrical charge. Resistance, measured in ohms, opposes this flow. Familiarity with Ohm's law, which states that voltage equals current times resistance, or volts equals amps times ohms, is essential. You will probably encounter questions about electrical circuits, especially series, parallel, and combination circuits. In a series circuit, components are connected end to end, so the current is the same through each component while the voltage is divided among them. The total resistance in a series circuit is the sum of the individual resistances. In a parallel circuit, components are connected side by side, so the voltage is the same across each component, while the current is divided among them. The reciprocal of the total resistance in a parallel circuit is equal to the sum of the reciprocals of the individual resistances. Combination circuits involve both series and parallel connections. Another probable topic is alternating current or AC and direct current or DC circuits. Direct current flows in one direction only, like from a battery. Alternating current periodically reverses direction and is what powers most homes and businesses. Understand the characteristics of AC waveforms, including frequency measured in hertz, voltage, and current. Root mean square or RMS values for voltage and current are crucial for power calculations in AC circuits. Transformers are used to step up or step down alternating current voltages. They operate based on the principle of electromagnetic induction. A transformer consists of two or more coils of wire wound around a common core. The ratio of the number of turns in the primary coil to the number of turns in a secondary coil determines the voltage transformation ratio. Motors and generators involve the conversion of electrical energy into mechanical energy, and vice versa. Motors use electromagnetic forces to create rotation, while generators use mechanical energy to induce an electrical current. Understanding the principles of operation for different types of motors, such as DC motors, induction motors, and synchronous motors, is essential. Generators also come in various types, including DC generators and AC generators. A crucial area is electrical safety. This includes grounding, bonding, overcurrent protection, and safe work practices. Grounding provides a low resistance path for fault currents, helping to protect people from electric shock. Bonding connects metallic parts together to equalize their potential, reducing the risk of shock. Overcurrent protection devices, such as circuit breakers and fuses, interrupt the flow of current when it exceeds a safe level. Also, it is important to understand the National Electrical Code or NEC and other applicable safety standards. To gauge the exam-specific requirements, always consult the official syllabus or study guide. This document should outline the topics covered and the expected level of detail. Firstly, start with the syllabus to identify key areas. Secondly, utilize textbooks, online resources, and practice problems. Thirdly, ensure a solid understanding of fundamental concepts before advancing. Fourthly, practice problem solving to reinforce your knowledge. Fifthly, take practice exams to simulate the actual test environment. Begin by reviewing basic electrical theory, including atomic structure, electron flow, and the definitions of voltage, current, resistance, and power. Power, measured in watts, is the rate at which electrical energy is transferred. Understand the relationships between these quantities as expressed by Ohm's law and the power equation, which states that power equals voltage times current, or watts equals volts times amps. For circuit analysis, master series, parallel, and series parallel circuit configurations. Learn to calculate total resistance, current distribution, and voltage drops in each type of circuit. Apply Kirchhoff's current law, which states that the total current entering a junction equals the total current leaving the junction, and Kirchhoff's voltage law, which states that the sum of the voltage drops around a closed loop equals 0. When studying AC circuits, understand concepts like frequency, period, amplitude, phase angle, impedance, reactance, and power factor. Inductive reactance is the opposition to current flow caused by an inductor, and it increases with frequency. Capacitive reactance is the opposition to current flow caused by a capacitor, and it decreases with frequency. Impedance is the total opposition to current flow in an AC circuit, and it is the vector sum of resistance and reactance. Power factor is the ratio of real power to apparent power, and it indicates the efficiency of power transfer. Analyze single-phase and three-phase AC circuits. Three-phase systems are more efficient for power distribution than single-phase systems. Understand the different types of three-phase connections, such as Y and delta. Transformers are critical components in electrical power systems, so thoroughly understand their principles of operation, construction, and applications. Learn about different types of transformers, such as step-up transformers, step-down transformers, isolation transformers, and autotransformers. Pay attention to transformer ratings such as voltage rating, current rating, and power rating. Understand the concept of transformer impedance and its effect on fault current. For motors and generators, study the operating principles, characteristics, and applications of various types, including DC motors, AC induction motors, synchronous motors, and universal motors. Understand the relationships between motor speed, torque, and horsepower. Learn about motor starters, motor controllers, and motor protection devices. For generators, understand the principles of electromagnetic induction and how mechanical energy is converted into electrical energy. Learn about different types of generators, such as synchronous generators and induction generators. A thorough understanding of electrical safety is crucial for passing the exam and for working safely in the electrical field. Study the NEC and other relevant safety standards. Learn about grounding and bonding requirements, overcurrent protection, and arc flash hazards. Understand the importance of personal protective equipment, or PPE, such as gloves, safety glasses, and arc-rated clothing. Be familiar with lockout-tagout procedures for de-energizing electrical equipment before performing maintenance or repairs. In addition to studying the specific topics outlined in the exam syllabus, develop your problem-solving skills. Work through as many practice problems as possible. Pay attention to units and conversions. Double-check your work to avoid careless errors. Also, consider attending a review course or joining a study group. These resources can provide valuable insights and support. Manage your time effectively during the exam. Read each question carefully before attempting to answer it. If you are unsure of an answer, move on to the next question and come back to it later if you have time. It's good to familiarize yourself with the NEC. While you may not be required to memorize specific code articles, understanding the general layout and content of the NEC is helpful. Learn how to navigate the codebook and find information quickly. Key sections to focus on include Article 210 for branch circuits, Article 220 for calculations, Article 250 for grounding and bonding, Article 300 for wiring methods, Article 310 for conductors, Article 400 for flexible cords and cables, Article 430 for motors, Article 450 for transformers, Article 500 through 516 for hazardous locations, Article 600 for electric signs and outline lighting, Article 680 for swimming pools, fountains, and similar installations, and Article 700 for emergency systems. When solving calculation problems, pay close attention to the given information and what the question is asking for. Identify the relevant formulas and apply them correctly. Be sure to use the correct units and conversion factors. For example, you may need to convert between horsepower and watts, or between circular mils and square inches. Practice solving different types of calculation problems, such as voltage drop calculations, conductor sizing calculations, and overcurrent protection calculations. Voltage drop calculations determine the voltage drop in a conductor due to its resistance. Conductor sizing calculations determine the appropriate size of conductor for a given load. Overcurrent protection calculations determine the appropriate size of overcurrent protection device, such as a circuit breaker or fuse. In addition to calculation problems, expect to see conceptual questions that test your understanding of electrical principles and safety practices. Read these questions carefully and consider all the answer choices before selecting the best one. Look for keywords and phrases that may provide clues. Eliminate answer choices that are obviously incorrect. If you are unsure of the answer, make an educated guess based on your knowledge and understanding. Remember to stay calm and focused during the exam. Avoid getting bogged down on difficult questions. If you are struggling with a particular question, move on and come back to it later. Pace yourself so that you have enough time to complete all the questions. Review your answers before submitting the exam to catch any errors. One should understand electrical blueprint reading. You might encounter questions that require you to interpret electrical drawings and diagrams. Be familiar with common electrical symbols and notations. Understand how to identify different types of equipment, circuits, and wiring methods on a blueprint. Practice reading electrical blueprints and diagrams to improve your skills. You need to know about power distribution systems. Understand the different types of power distribution systems such as radial, loop, and network systems. Learn about the components of a power distribution system such as substations, transformers, switchgear, and protective devices. Understand the advantages and disadvantages of each type of system. You will need to know about renewable energy systems. With the growing interest in renewable energy, you may encounter questions about solar, photovoltaic, or PV systems, wind power systems, and other renewable energy sources. Understand the basic principles of operation for each type of system. Learn about the components of a renewable energy system, such as solar panels, inverters, wind turbines, and batteries. Understand the requirements for installing and maintaining renewable energy systems. Here are some examples of possible exam questions. What is the voltage drop in a 240-volt circuit with a 10-amp load in a 100-foot run of 12 American wire gauge or AWG copper wire? What size overcurrent protection device is required for a 15-amp motor? What is the grounding requirements for a metal enclosure containing electrical equipment? What is the safe working distance from exposed energized electrical conductors? How do you calculate the total resistance of resistors in parallel? What is the purpose of a transformer? What is the difference between a circuit breaker and a fuse? What is arc flash? What is the purpose of grounding and bonding? What is the NEC? If you can answer these questions, you are well on your way to passing the electrical portion of the exam. Always prioritize safety when working with electricity. Follow all applicable safety codes and standards. Wear appropriate personal protective equipment. Never work on energized electrical equipment unless you are properly trained and authorized. If you are unsure of something, ask for help. Electrical safety is everyone's responsibility. Remember to consider these additional tips. Get plenty of rest the night before the exam. Eat a healthy breakfast. Arrive at the exam location early. Bring all necessary materials such as pencils, erasers, and a calculator. Read the instructions carefully before starting the exam. Stay calm and focused. Manage your time effectively. Review your answers before submitting the exam. Good luck!